Welcome to my YouTube channel. Today we will see how can you solve differential equation which is of the type dy by dx f of ax plus by plus c. To solve these type of differential equation, our first step is to put ax plus by plus c into another variable t. After that, we will differentiate this with respect to x. That means d by dx ax plus by plus c, that is equals to dt by dx. We will get here after derivative a b dy by dx, that is equals to dt by dx. Then b dy by dx, that is dt by dx minus a, and dy by dx, that would be 1 by v dt by dx minus a. By solving this, this equation can be converted into 1 by v dt by dx minus a, that is equals to f of t. Your equation will become dt by dx minus a f of t into b. Now you have to solve this simple differential equation either by using variable separable method or whatever the possible method to solve the equation, we will get a solution. Now let us see the question, how can you solve these type of equation. Now have a look for one question. The question is given to you, the question is solve differential equation x plus y plus 1 square dy equal to dx. Now how can you write it down? Dy by dx, that is equals to 1 over x plus y plus 1 square. So our first step is to put x plus y plus 1 into another variable t. Then we will find derivative with respect to x. Derivative with respect to x, it will give you y. This is dy by dx. This is dt by dx. So dy by dx, that is equals to dt by dx minus 1. From here, we will get the value of dy by dx in terms of dt by dx. So we will put this value in our equation, that is dt by dx minus 1. Here is 1 by t square. After that, dt by dx, that is 1 by t square plus 1. Further, how can we solve it? Dt by dx, that is 1 plus t square divided by t square. Now we can use here easily variable separable method. Variable separable method means the terms containing t, that is on one hand side, and the terms which containing x, that is on another hand side. After doing this, we have to just integrate it. We can easily find integration of this, that would be x. Here is a constant c. Now the question arises, how can you find integration of this? To find integration of this, Firstly, we will add here 1 and we will subtract here 1. So, how can you solve further? To solve this equation further, we will add here 1 and subtract here 1. Like, it would be a t square plus 1 minus 1, 1 plus t square dt x plus c. So we will separate the denominator 1 plus t square, 1 plus t square minus 1 plus t square dt, that is x plus c. Further, first term is cancel out. So if the first term is cancel out, you will get here 1 minus 1 over t square dt x plus c. Now integrate by part. 1 into dt, 1 over t square dt x plus c. It would be a t minus, what is the integration of this? That is tan inverse t x plus c. After solving this type of equation, what we will do further? We will further resubstitute the value of t. Now what is the value of t? Our value of t is here, that is x plus y plus 1. So we will put here t as x plus y plus 1. So see, if we will put t here x plus y plus 1, we will get tan inverse x plus y plus 1 x plus c, and left over here y plus 1 minus tan inverse x plus y plus 1, that is equals to c. So this is our required solution of our differential equations. Thank you very much.